Did you have a look at some of yesterday's recordings?
Yes, sir. I've checked the recordings. I was having an error, sir, about the module sklearn
Okay.
was showing some error. So I was working on it actually.
Okay, that's fine. So please just sound out to your friends that we ask them to join, so that in another 1-2 minutes, I'll just get us a bottle of water and I'll join you in maybe in half a minute's time.
Sure, sir.
Okay, how many of you have joined as of now? We hardly anybody, just 3-4 of you. Please ask your other friends to join, and another 1 minute we will start off. We will not wait too much. Otherwise, it becomes a headache. For, I mean, we as it is, we are falling short of time. Let's not get into this that we keep waiting for another half an hour, 45 minutes just to wait. Ask your friends to join. Please ask another couple of you more to join. And this code which you see at this 35 of mine, I've just opened the same thing which has now become 36. We are done till here. So I'll request you, please do one thing, open up the same code, and when you open it up, you'll have to rerun the entire code for you to reach over here. And if you remember also during yesterday's session, what did I tell you? I told you that this concept demands good amount of Python from you. And how do you learn Python? Definitely your college, you would have had umpteen sessions in your college for you to pick up on Python. Little bit, you'll have to also do some self-study so that you catch up with this growing trend in Python. Okay, can we start? Yeah, we have had few more of your people joining us. Great. That's wonderful that few more of you have joined. Let's start our session because we're already 2 minutes down the line. Okay, see what we did till here, this last thing what we did, where we took this rooms per household, bedroom per room, and population per household. We have drawn up this formula where we have written like the rooms per household is the total rooms divided by the number of household, and bedroom per room is nothing but the total bedroom divided by the total room, and population per household is nothing but population divided by the household. Has anybody got any doubts still here to ask me? If you have got doubts, please ask me. Otherwise, let's proceed. Let's go ahead with what we were doing. Okay, anybody, anything?
No, sir. Let's continue.
Okay, fine. What we will do now, see, in order to have a better look at this data, what we need to do, we need to draw up the correlation matrix. And I am very sure you know how to draw the correlation matrix. I'll just say for the correlation matrix, I'll say CORR underscore matrix. This is nothing but my housing dot CORR. And this will help me draw my correlation matrix. Now what I want, this correlation matrix which I want it to focus mainly on the median housing value. So I would say CORR underscore matrix of my median house value, this and I want to sort this value in descending order. So what do? I would say sort underscore values, and I say ascending is false. Now let's run this. Wonderful. I get the correlation matrix. But please compare this correlation matrix with the one which we got in 31. See, the one in which I got in 31 here, the difference is here the values range from -1 to +1. Whereas in the one which we just now got, see this, see the values. That means here the odd out in this thing of mine is this bedroom per room. That means it says this bedroom from room is something minus 0.2, still more down. This bedroom per room attribute is much more correlated, I would say, with the median house value than the total number of rooms or bedroom. See, apparently what happens, houses with lower bedroom per room ratio tends to be more expensive. And the number of rooms per household is also more informative than the total number of rooms in a district. And obviously, friend, the larger the house, the more expensive they are. This round of exploration, what we have done till now, does not have to be absolutely thorough. The point is to start off on the right foot and quickly gain insights that will help you to get a first reasonably good prototype. But this is I would say, an iterative process. That is, once you get a prototype up and running, you can analyze its output to gain more insights and come back to this exploration step later. Now, see, all these things which we have done till now, what did we do? We were preparing our data for our MLA, that is machine learning algorithm. And please do not forget what is the whole sole purpose of doing this. We are doing predictive analytics of this complete data set of California housing. Now, when we prepare this data for our machine learning algorithm, I would say it is the right time that we need to push in our data into machine learning algorithm. Why? Because this allows you to reproduce these transformations easily on any data set. And you can also say that you will gradually, what you will do, you will build a library of transformation functions that you can reuse in future projects. And you can use these functions in your live system to transform the new data before feeding it into your algorithm. And what will this do? This will make it possible for you to easily try various transformation and see which combination of transformation works the best. So before we start going into anything, see, although this in 37 of mine, I have created a correlation matrix, which is basically, I would say, more or less the theoretical part of this correlation matrix. There are many people who say this kind of a correlation matrix is not comfortable. We want a visual plot. So I am very much sure you know how do you do a visual plot. So you should be saying housing dot plot. And what kind of plot do I want? Please understand, yesterday we told 100% of machine learning and deep learning problems use scatter plot, unless otherwise maybe for some specific reason. And here I would specify what is my X, which is nothing but rooms per household. And I also specify what is my Y. Y axis is nothing but my median house value. That's it. Now, apart from this, I have to let me give some value of alpha, a low value of alpha, which we had spoken of yesterday. I would say 0.2. Now, what happens after this? What do I specify? I have to specify my what is it? The values which I want on the x-axis and my values on the y-axis. So how do I say? I'll say plt dot axis. I'll say on the x-axis have it from 0 to 5, and on the y-axis have it from 0 to 50 to 5,20,000. So 5,20,000. So this I would say. And now when we get into plotting, we will get a beautiful plot. There are some people who say rather than just coming out with some numbers, it's better if you have plot of this kind. Now, Definitely. Also, one more thing which you would be required definitely to do is you have to, before going even an inch ahead, you have to describe this data and see how well or how descriptive this data is, for which you know what should be done, what needs to be done. I'll say it is housing dot describe. I find out the descriptive statistics of this data. It gives me the complete descriptive statistics, the count, mean, standard deviation, minimum, maximum, the Q1 quartile, Q3. You can definitely, looking at this data, you can find out the IQR, which is interquartile range. Now, after, do you need some time to write this? Tell me, friends, do you need some time to write this? You are very few of you today. Tell me, Sadaf, do you need time to write this?
No, sir, I'm noting it down. Already noted it.
Okay. Now we said that we are preparing this data for MLA, machine learning algorithm. So, and for me, the dependent variable over here is the median house value. So what I need to do, I need to specify two simple lines in Python. I would say my housing is strat underscore of the strain. That is, I'm finding a stratified, doing a stratified sampling of the trained data set. I said this, and now see, although we have taken this median housing value, I have to throw it off. That is, I have to drop this value because I don't need it. It will create trouble for me in my due calculation. After that, what I'll do, I'll take a complete copy of the data set, and then I do stratified sampling of that data. And we spoke yesterday why at all should we do stratified sampling. So now I say my housing is strat train set dot drop. Or what do I need to drop? I need to drop my median house value, and this I need to do in column. So I say access equal to 1. Then I would say my housing labels is nothing but my stratified train set of my median house value. And I would say, please do one thing, create a copy of this, because it might so happen that when you're working with this data, this or even huge amount of data, you might bugger up the data. So before you spoil the data, it's better taking a copy of the data. I run this fine. It is very comfortable what we have run till now. Now comes the concept where we do the concept of data cleaning. Please understand, friends, this most of this MLA, this machine learning algorithms, cannot work with missing features. So what we do, we will create a few functions to take care of them. We have earlier seen that the total bedroom attribute has some missing value. Do you remember this? When we saw this initial, see this, the total bedroom attribute here. It says the total bedroom is 20,433, whereas all others are 20,640. So that means total bedroom has some missing attribute. What we will do, we'll fix this. But please understand, you've got three options to fix this. The first, you can get rid of the complete or the corresponding districts. Second, you can get rid of the whole of the attribute. And the third, replace that with some value, maybe 0, it can be mean, it can be median, it can be some predictive function or anything. How do I do this three things? There are three different ways how I want to do this. But before you even attempt to do this, first you need to find out, are there any null values in your data set? Can somebody tell me how will I find out if there are any null values in this housing data set? This data set is housing. I only would request you remember what we did yesterday. It's just a continuation of that. Tell me, please, how do I find out if there are any null values in this data set? Tell me, Sadaf, how do I find out? I would say sample. Let me take as my variable sample incomplete rows. As this is variable, anything I can take this. I would say housing of housing. I use this is null function of Python, is null, and I would say with any access, find out anywhere in the data set if there is any missing value. I say go along the column, and I want it to read out the head value, that is give me the top 5 rows. And when I call back the sample incomplete rows, see what do I get as output. It tells me there are some missing values in total bedroom. That is why the numbers are less. There are some nan values, means not a number. What does nan stand for? Not a number. So there are some nan values in this missing data set. Let me arrest those problem. We said there are 3 ways how we can arrest the problem. First, get rid of the corresponding districts. Second, get rid of the whole attribute. And third, replace it with some value, maybe the zero, mean, or median. We will see all 3 of them. First, let's see the first option, that is getting rid of the complete districts. To get rid of the complete district, what I will say, I'll say sample complete rows dot drop na of my subset, which I would say is nothing but my total bedroom, because see total bedroom has got nan value. So I say this as total bedrooms. This is my first option. I run this. It will knock off all the thing, whatever, drop NA. It will drop NA for all these things, wherever this is there. Now, the second option is getting rid of the whole attribute. So once again, for that, I'll copy the sample incomplete rows dot drop off, I would say, drop this total bedrooms, and this I would say please do it along the column. So I say access equal to 1. By this, what am I doing? I am dropping the getting rid of the whole attribute. The third option, which is the most preferred option, is I will find out the median. I can find the mean, median, mode, whatever, and replace those missing values. But professionally, median is the most preferred. So we will just find out the median. I'll say median of housing of this total bedrooms, and I say please find out the median. This will give me the median value. Now I want to replace all the missing value with median value. So I say sample underscore incomplete underscore rows of my total bedrooms. I want to fill NA, fill all the NA values with the median value, and I say in place as true. Now this is my third option. Fine, any one of this which you want you can choose, but professionally it is the third option that is chosen. That is what I am going to do. I am going to replace all these missing values with the median value of this complete column. With the complete column, I am going to replace it with the median value of this complete column. Now after we do this, since I have told I want this rows to be deleted or fill it with this median value, when I just call this variable, let's see the data set. See, all the nan values are gone. It has got replaced with 433 here. That is the median value. No problem, fine. It has done the job what I require. But do you need some time to write it down? I want you to be with me, not
Just a
lagging
minute,
behind.
sir.
Yeah, please. Anybody having any kind of a doubt, anytime, you can stop me wherever and ask me. Don't wait for me to ask you. Because once I get into this mood of solving, I'll keep solving it. It does not mean that I'm ignoring you. It is if you got a doubt, you can stop me and ask me whenever, wherever.
Let's continue, sir.
Okay, fine. See, but doing all these things what we have done till here, see there is another one simple technique which Python helps you. and in particular scikit-learn. Scikit-learn says, why do you want to do all this? It gives you a simple function called simple imputer. When you use the simple imputer, you first need to create a simple imputer instance specifying that you want to replace each attribute's missing value with the median of that attribute. So how will I do it? First, I need to import this simple imputer. Where is simple imputer? Definitely it is a part of this sklearn library. So I will say from sklearn.impute, please import simple imputer. And I have to specify what will this imputer do. I want this imputer to replace all the missing values with the median of that column. That is the mid value. So I would say my imputer is simple imputer, and I specify uh, my strategy as what? As median. That's it. When I do this, it will replace all the missing value with median value. But now you need to remember, friends, this table which you see in this 45 of mine, the last one is ocean proximity. Ocean proximity is a categorical variable. It has got all text. How can you find the median of a text? Not possible, because median can only be calculated on numerical attributes. So what we will do, we will run this imputer function on this ocean proximity, or what we will do, we will drop this ocean proximity, delete it from here, drop it. I won't say delete, I just drop it, and thereafter get into computation of median. So in order to do that, what will I do? I would say, let me remove my annotate. Yeah, so what I would say, I want to drop this ocean proximity. I would say housing underscore num is nothing but my housing dot drop of my, what do I want to drop? Of my ocean proximity, and I want this to be done along the column. So axis equal to 1. This will help me drop this ocean proximity. Now I will push in this imputer function into this data set and ask Python, what are you doing? So when I do this, I'll say imputer dot fit, I would say is housing underscore num. So this is, by this I'm asking Python, what are you doing? Python tells me I'm finding out replacing all the nan values with the median value. But I still don't believe Python. I don't trust Python. I will tell Python, please give me the statistics of what you have done. So I would say imputer dot statistics underscore. It should give me the statistics of what Python has done. Now I'm comfortable that what Python is telling me is a fact, that it has replaced all these values with the median value. Now to check that this is the same as the manually computing the median of each attribute, how do we check whether if it is the same as that when you do it manually or not? Because once again, I am saying that your right hand should not trust your left hand. Till the time you are under this concept, you will become a wonderful programmer. Once your right hand starts trusting your left hand, you are in trouble. So since Python has told me, the imputer says this is the statistics, let me once again do it manually and see if the results are the same. For which, what should I do? I'll say housing underscore num dot median. I want all the values to be displayed. I say values. So this will give me my manual calculation. Compare that with this, exactly the same. That means Python is not lying to me. We are all comfortable with what Python has told me. Now, after I do all this, what I need to do, I need to transform the training set. Why? Now you can use this trained imputer to transform the training set by replacing missing values with the learned median. How do I transform the data set of this housing data set? I'll say x is imputer dot transform of my housing underscore num. This will help me transform my data set. It says I have found out that I've transformed your data set. Now, the result I would say here is a plain NumPy array. That is, let me just call back my extension. See, it is a simple NumPy array, which is of no use, which contains the transform features. But now what I want this to be put back into Pandas data frame. How do I do it? Very simple. Definitely you will be knowing. I'll say housing underscore tr. If I take as my variable, I'll say pd dot data frame of my variable x, and I say my columns as housing underscore num dot columns, and I specify my index as housing underscore housing dot index. So this should give me my transformed housing data set. Now let me just call back my housing underscore tr and see whether I've got a data frame or not. Beautiful. It gives me my data frame. 16,512 rows and 8 column. You may kindly write this and let me know. Do you want me to go up a little bit for you to write? Tell me.
So let's continue.
Okay. Or is it that because majority of you I find are on mobile, how will you write something if you're on mobile? You're just listening to this like a cricket commentary. You will, friends, this thing what I'm telling you is extremely essential as on today, anywhere in the world. We are doing a state of art problem for me to prove to you this concept of predictive analytics. Although this 8 sessions I won't be able to do more than one problem, I'm in depth doing it for you to prove to you what is that you need to learn when you do predictive analytics and practically solving it for you. Okay, now since we have found out this housing under, so this transformed housing data set, but still I don't believe what Python has done for me. Let me say ask Python what is the strategy that Python has employed, for which I will say imputer dot uh, strategy. When I ask Python, it should tell me it is median. Yes. Now I would say fine. What Python has done for me is using this imputer function, it has found the median for me. Now, what we will do, we will just refine this data frame of ours which we have got. For which, what I'll say housing underscore tr is pd dot data frame of my variable x, and columns I would say is housing underscore num dot columns, and I specify my index as housing underscore num dot index. This should give me this housing tr data set. Now when I call back my housing tr, it should give me my wonderful data frame. Done. I have got all, that is the missing values has been replaced by the median values. Now I find it comfortable. But please remember one thing, all through in this example we have been neglecting the text attributes or this categorical attributes, which is nothing but ocean proximity. We have to handle that. How can you let go one column of the data set without even considering that? We have to take care of that. For which, what we will do, we will read the first 10 values of this ocean proximity, which is a part of this housing data set. So let me say my variable I take as housing underscore cat. This is nothing but housing of, I would say, ocean underscore proximity. And now when I say, please tell me or the top 10 entries of this housing cat, I would say housing underscore cat dot head 10. It should list out 10 attributes or top 10 attributes, which says ocean, inland, whatever. You may kindly write this and let's go ahead after this. See, what are we doing now? We are handling this categorical attribute. Tell me, please, whenever you complete it.
Let's continue.
Yeah, thank you. See, this what we have got is not an arbitrary text. There are a limited number of possible values, each of which represent a category. So this attribute, what we have got in this 58 of mine, is a categorical attribute. See, most of this machine learning algorithms prefer to work with numbers. It is very difficult when you have text. So what we will do, we will convert these categories from text to numbers. Can you please tell me which feature of Python do I use for this to convert from text to numbers? Anybody? Sadaf, can you tell me which library or which function of Python will I use to convert this categorical variables from text to numbers?
Not sure, sir.
Okay, how much ever you're sure, you can tell me. Since you're not sure, so maybe something little bit, you can help me out with it. Okay, what we will be using ordinal encoder. So what I have to do before I use this ordinal encoder, I have to pull it in. So where do I get ordinal encoder? Once again, it is a part of this sklearn library. So I'll say from sklearn dot preprocessing, I will import ordinal encoder. Now I would say, let me create a model of this ordinal encoder because I'm going to use this. I'll say my ordinal underscore encoder is nothing but my ordinal encoder. Now what I need to do, since this is the model which I've created, I have to push in all my data into this model. So I take my variable as housing cat encoded, and this here I would be using this ordinal encoder to push in all my data into this model. I will say ordinal underscore encoder dot fit underscore transform of this housing category. That's it. Now if I want the top 10, say the top 10 rows of this housing encoded to be listed for me, what will I say? I will say my housing, this thing, a cat encoded, and within square bracket, I'll say colon 10. So this should give me the top 10 values of this housing cat encoded. Now, what do you see here? A wonderful. You can write it after that. I would tell it to you. These are some wonderful functions in Python. Definitely, even I would expect that by the time you finish this course, if not your whole class, at least handful of you should be so good in Python that you should tell me this is a wrong function you use this. Great. You should be able to dictate terms. That will really be wonderful. Even when you're writing it, ensure that you get the same output. I'm very much sure that yesterday what we did, you must have forgotten by now. It should not happen. So whatever you write, make sure that you put comments and write so that later whenever you open it, it's comfortable to you.
Let's continue, sir.
Okay. See, what we can do after this, we can get the list of categories using this categories instance variable. And what is this categories instance variable? It is a list containing a ID array of categories for each categorical attribute. And in this case, a list containing a single array, since there is just one categorical attribute, which is that ocean proximity. Since there is only one categorical attribute, we will get what are the instances of this categorical attribute, for which what I need to do, I need to say ordinal underscore encoder dot categories underscore. This will help me get my instances of this, which is ocean, inland, island, near bay, near ocean, whatever. All these are the various categories with this. Now there is a small problem. One issue with this kind of representation is that this machine learning algorithms will assume that two nearby values are more similar than two distant values. So this may be fine in some cases, that is for you can say for ordered categories such as bad, average, good and excellent. But what happens is that it is obviously not the case for this ocean proximities column of this data set which we are considering. So to fix this issue, a common solution is to create one binary attribute per category. That is one attribute equal to this number 1 when the category is ocean and 0 otherwise. See, another categorical attribute equal to 1 when the category is say inland and 0 otherwise. This technique is what is called as one hot encoding and is extensively used in almost all problems in the industry. So because here only one attribute will be equal to number 1, which is called hot, while the others will be 0, which is called cold. The new attributes are sometimes also called as dummy attributes. And scikit-learn helps you out over here by providing a wonderful function called one hot encoder, which helps you to convert categorical values into one hot value. How do I do it? Let's see. First, what I need to do, I need to import this function, which once again is a part of this sklearn library. So what do I say? I will say from sklearn dot pre-processing, I want to import one hot encoder. Then I would create my model. I'll say cat underscore encoder is nothing but my one hot encoder. This is my model. Now, as what we have been doing, we will push in all the data into this model. So I'll say housing underscore category underscore one hot. If I take as a variable, I'll say my cat underscore encoder dot fit underscore transform of my housing category. Now when I call back this variable housing cat underscore one hot, let's see what I get. Beautiful. It says it is a sparse matrix. Don't worry. Although you're not able to see any output, it says it's a 16,512 rows and 5 columns of sparse matrix. But here the problem is we have got a sparse matrix instead of a numpy array. Understand that this is very useful when you have categorical attributes with thousands of categories. After this one hot encoding, we get a matrix with thousands of columns, and the matrix is full of zeros except for single number 1 per row. And using maybe this will use up to tons of memory, mostly to store zeros, would be very useful. So instead, a sparse matrix only stores the location of the non-zero element. So you can use it mostly like this normal two-dimensional array. But if you really want to convert it to a dense array, that is a densest numpy array, what you will do, you will just use the two array method. So when I use the two array method, I'm going to convert the sparse matrix to an array. So what will I do? I will say housing and underscore category underscore one hot dot to array, and it will give me an array of all these zeros and ones. Wonderful. Nothing else other than 0 and 1. As an alternative, what you can do, you can set this sparse equal to false. You can specify this when you create a one hot encoder. See, what I'll write right now is another alternative to what you can do. Another alternative we said is you can specify this sparse as false. That is what you can do. You can say category underscore encoder, which is nothing but one hot encoder, and I specify my sparse as false. That's it. And now what I will do, I'll say my housing underscore cat underscore one hot, this one as my category underscore encoder dot fit in my data. I use the fit transform function of my housing underscore cat. Now, when I call back this housing cat underscore one hot, let's see what I get. I should get the same array which I got in 62. Wonderful. It is the same array. You may write it down and please let me know. And this time when you write, I'll request you please write it with ample comments so that the next time when you open it, it sounds meaningful for you.
Let's continue, sir.
Yeah. Has anybody got any doubts till here?
No, sir.
Okay, so once again, what we will do, we can get the list of categories using the encoder's category instance variable. How do we do that? I have to just say category underscore encoder dot categories underscore. I'll get, once again, I will get all the attributes, that is all the categories under the encoder's categories instance variable. See, one thing which you will need to remember at this point is that if a categorical attribute has a large number of possible categories, say we have country code, profession, species, and so on and so on and so on, then using this one hot encoding will result in a large number of input features. It will result in a very large number of this input features, and this may slow down training and definitely degrade the performance. It will slow down your training and degrade performance. Now if this happens, you may want to replace the categorical input with useful numerical features related to the category. For example, you could replace the ocean proximity feature with the distance to the ocean. Similarly, maybe a country code could be replaced with country's population and GDP per capita. Alternatively, you could also replace each category with a learnable low dimensional vector, which we will call it as embedding. And each category's representation would be learned during training. This is a wonderful example of what is called as representational learning. Now, after we having done all this, although please understand that scikit-learn provides many useful transformers, you will need to write your own for tasks such as maybe the custom cleanup operation or combining specific attributes. You will want your transformer to work really seamlessly with scikit-learn's functionality. And which is this functionality? It is maybe like pipelines. And since scikit-learn relies on what is called as duck typing and not the inheritance, all you need to do is create a class and implement three methods. Simple, very simple, three methods. The first is fit, which will return self, then is transform, and the third one is fit underscore transform. And you can get this last one, that is fit underscore transform, for free by simply adding transformer mixin as a base class. Now, if you add base estimator as a base class, definitely in Python, you must have learned about args and quarks. Args are arguments and quarks are keyword arguments. So this base estimator is added to the base class to avoid args and keyword arguments in your constructor. You will also get two extra methods called this get parameters and set parameters that will be useful for automatic hyperparameter tuning. Now, for example, what we will do, we will write a small transformer class that adds the combined attributes as what we had till now discussed, for which I should start off by importing this base transform base estimator and this transformer mixin. These are two wonderful functions. So where is that these are resident? These are resident at sklearn library. So this is a very powerful library, friends, sklearn. So I'll say from sklearn.base import base estimator and transformer mixin. Then what we do indexing of the column. So we specify the column index, which let me take it as room underscore ix, bedrooms underscore ix, population underscore ix, and households underscore ix. This I take as my four different variables, which I'll give it value 3, 4, 5, and 6. Now what I will do, I'll create a class called the combined attribute adder of this base estimator and transformer mixin. And we will basically, this we are doing to find out this attribute adder and housing extra attributes. So in order to do that, we have to create a small little function, which or a class, I would say. I'll say my class will be combine attributes adder, and which of this base estimator and transformer mixin. This I create and make this conditional. And now I would define three functions within this class. One is self, one is fit, and the third one transform. We had just some time back spoken about this. The first function will be define. It will be my self. That is, I will say init of myself, and I will add one second, add bedrooms per room, which I would say I'll set it to true. And that means this I've set it to true because there are no arguments and no keyword arguments. Then I would say, making this conditional, I would say self dot add bedrooms per room, which is nothing but add bedrooms per room. That's it. This is my self function. Now the next one, I define a fit function. We had just spoken about this some time back. So I'll say define this fit of my this self and x comma y. I would say let this y be none. Make it conditional. And here what do? I return myself because there is nothing else to do. Now the third function is my transform function. So I will define my transform of myself and x, making this conditional, and I would say rooms per household is nothing but my this x variable x, all values, and I take this rooms underscore ix. Then this thing I'll divide it with this variable x, and taking all values I use my households underscore ix. So this should give me my rooms. Oh no, this is spelling mistake. Rooms per household. I also need to find out the population per household. I'll say population per household, which is nothing but my x of all the values I take and my population underscore ix. This will give me my population per household, but this value I have to divide it by x of all the values and my households underscore ix. After this, what do? Now what if I have to specify a if statement? I have to say if this add bedrooms per room, self dot add bedrooms per room. If this is this, then I would say bedrooms per room is nothing but my x of my all values of this bedrooms underscore ix. This will be this one divided by x of all values and rooms underscore ix. This will be my bedroom per room. After this bedroom per room, I find out I have to return my np.c underscore of this rooms per household, population per household, and bedroom per room. I have to return it. So I say x comma rooms per household and population per household and bedrooms per room. So this, since I have specified a if statement, I have to close it with else. Else this will be for all other condition, it will be return np.c underscore of this value of x and rooms per household and population per household. Let's once execute and see if you are facing trouble. Great, no errors. You can write this till here, then we will proceed. Has it been a little longer code? Once again, I would like to remind all of you that this activity of you publishing a paper in Scopus Index Journal is still pending, except for one team offhand which I remember. I think the team comprising of Saida and some other person, some other boy or girl, I don't know, I think some other boy or girl of your class. They have sent me the topic, which I've polished the topic and suggested a wonderful topic for them to write on. Nobody apart from them has got back to me. Friends, please don't wait for the last day. It's going to be a disaster. Any problems, anything you got, drop a mail to me, not WhatsApp. Drop a mail to me. Definitely, we'll help you out. For sure, we'll help you out. But don't remain silent. I really won't know what it is. What is that which is going on in your head? Please come up, speak to me. What is that you want? I'll only suggest everybody to maximum use of this wonderful opportunity which your college is providing for you to learn state of art topics, which will definitely help you for all those of you who would seek a job after your engineering, which I would say has to be done. You have to work. Whether you're a boy or a girl makes no difference. You have to work. So at that time, you'll find all these doing really well. A few years back when I was working at Oman, my very close friend, or my very, very close friend, even to this day, is a Pakistani boy, very brilliant boy. When they can do, why can't you do? Definitely, you can also do. Please write this, what I've written in 65 of mine, and you may let me know so that we can proceed ahead. This is a huge thing. We please understand, in 8 hours, we are just solving one problem. It takes a good amount of efforts. It is really nice that we have not encountered any major problems till now. You may write it, execute it also, and see that you're not getting any errors. Don't worry, I'll wait for you. This is not a 100 meters race that I quickly need to finish it. For your understanding, a small little professional information. See, when you do any of these problem in machine learning, whether you're doing it in machine learning or deep learning, you got three options for you to do, or three different libraries you can take for yourself to solve the problem. The first is TensorFlow. All the problems can be solved using TensorFlow. The second is Scikit-learn. Scikit-learn. You can do all the problems even using Scikit-learn. The third is Keras. As on today, these are the only three libraries you can use to solve all this problem. Incidentally, what we are using Scikit-learn. It is not that I can't teach you in TensorFlow. It is little more difficult. So I felt the easiest one being Scikit-learn. I'll teach you in Scikit-learn. There is one N which is missing. It is population per household. Some small little thing. It will definitely throw out error later. Yeah, no errors. So you may tell me if you're completed. We can then move ahead.
Let's continue, sir.
Yeah. See, we are still two more things we need to write in this class which we have created so that we are able to square it up. Now, after defining this class, I have to also say what are my added attributes adder, and what are these housing extra attributes which I've added to this. So I'll continue this. I'll say attr underscore adder as combined attributes adder of my add bedrooms per room, and this I would set it to false. And now I would also say what is my housing extra attributes. So I'll say housing extra attributes will be my attribute underscore adder dot transform of my housing dot values. So when we execute this, oh, there is some mistake. Rooms underscore ix is not defined. 1 second, we will have to go back and see this. It says the housing extra attributes is attr underscore adder dot transform of housing dot values. Let's go see the complete thing. So class of combined attributes, any spelling mistake of the adder or base estimator and transformer mixin, okay, and define in it, that is self add bedrooms per room, which is set to true. No, because no arguments or keyword argument. Then I have told self dot add bedrooms per room is add bedrooms per room. Okay. Then the second one, we have defined fit, which is this of the self, and x and y we have told us none. Then return self because there's nothing else to do. Then we have defined transform of the self and x, and rooms per household I have told x of all the values, and rooms underscore ix divided by x of all values and households underscore ix. Then population per household is x of this population underscore ix, and divided by the value of x of all values and households underscore ix. Then if self dot add bedrooms per room is bedrooms per room is x of this bedroom underscore ix divided by x of rooms underscore ix. Then return, we have told np.c underscore of this x rooms per household, population per household, and bedrooms per room. Else return np.c underscore x of rooms per household, population per household, and attribute adder combined attributes adder of add bedrooms per room, which is set to false, and housing extra attribute is attribute underscore adder dot transform of housing dot value. See, the problem with Python is one small mistake and it is going to give you a big headache. From a scalar dot base import base estimator transformer mix in, and my column index room, oh ho ho, this is rooms underscore ix, bedrooms underscore population underscore ix, households underscore ix. Now let's see. Wonderful, no error. Small mistake, it gives you sleepless night. Have you also corrected your mistake if you are facing any problem? No errors, absolutely no errors now. Or is it that you're having some other errors which is throwing up? Let me know after you have done it.
Let's continue, sir.
Yeah. See, in this example, which I've taken in the 68 of mine, we have used this household underscore ix as, that is the indices, which I've used as 3, 4, 5, and 6. Basically, I've hard coded the indices. This is basically for concision and clarity. But the right practical approach would be much clearer if you get them dynamically. That is, how do I specify them dynamically? Definitely I'll have to use something different. So I'll say my column underscore names will be my total underscore rooms and total underscore bedrooms, and I would also have to say my population and also my households. Now I would have to say my rooms underscore ix, bedrooms underscore ix, population underscore ix, and households underscore ix. This will be nothing but this. Basically, we are trying to get the column indices, which will be nothing but my housing dot columns dot get location. I get the location of this variable C, where I specify what is the C. I'll say for C in column underscore names. That's it. This is basically what I'm trying to do. I'm dynamically trying to get values of this household ix, which otherwise in my 68 I had specified this household ix as 3456. I'm dynamically trying to get values. Now also this housing extra attribute, which we know is a numpy array, using this we have lost the column names. Unfortunately, I would say this is a problem with scikit-learn. To recover this data frame, what you could do, you could run another one small function. Basically, since we have lost this, to recover it back, what will we do? We will say housing underscore extra underscore attributes, which is nothing but pd dot data frame of my housing extra attributes, and I would also specify my columns, which is nothing but a list of this housing dot columns, and this thing is a list of this, plus added to this will be my rooms per household, and also we will have my population per household. That's it. Now this, apart from this, I also would need one small thing, which is I need to specify my index, which will be my housing dot index. That's it. Now when I start reading my data set from top, that is housing extra attributes, I will say I want it to be read from top. So I'll say housing extra attributes dot head. It has to give me my first 5 rows of my data set. Wonderful. I am getting what I want. You may kindly write this and tell me, please. Have you done it?
Let's continue soon.
Yeah. Before we do even anything ahead, let me do the justice and let me take your attendance so that we finish off this attendance and then we can continue with what we were doing. So you're at kindly answer up because you're just a few of you today. It should not take much of a time for us to take your attendance. Let the attendance sheet open up. Yeah. Okay. What I'll do, I'll just unmark all. Keep you as okay. Fine. 63956. 733008. 733054. 733056. 733075. 733076. 733084. 733095. 737010. 737020. 737023. 737024. 733001. 733005. 733007. 733008. 733009. 733009 and 733010. 733012. 733013. 733014. 733016.
Present, sir.
Okay. 733017. 733019. 733020. 733021. 733022. 733023. 733027. 733028.
Present, sir.
733030.
Present, sir.
Okay. 733031. 733033. 733035. 733037. 733038. 733039. 733041. 733042. 733044. 733053. 733054. 733056. 733057. 733058. 733059. 733062. 733070. 733074. 733077. 733080. 733085. 733086. 73302. 733301. 73701. Sorry. 737004. 737008.
Sir,
737
04%.
04%. Okay. 737009. 737013. 737014. 737015. 737016. 737017. 737019.
Present, sir.
73719%. Okay. 737020.
Sir, 017 present, sir.
19%.
No, 19 absent, sir.
Okay, 19 absent. 737021. 737022. 737024. 737025. 737027. 737028. 737029. 7370331. 737033. 737034, 737039, 737040, 737042, 737044, 737046, 737052, 737053, 733002, 733003, 733004, 733007, 733008, 733011, 733012, 733013, 733014, 733014, 733021, 733024, 733025, 733029, 733031, 733034.
Present, sir.
Yeah, 733035. 733035 is absent. 733036. 733037. 733038. 733045. 733047. 733056. 733057. 733061. 733063. 733064. 7330 present 64.
Yes,
Okay.
sir.
733065.
Present, sir.
Okay. 733066.
Present, sir.
7336 present. Okay.
Yes, sir.
733067. 733068. 733069. 733071. 733072. 733073. 733074. 733075. 733080.
Present, sir.
7330. What's your number?
080.
080. Okay. 733081.
Present, sir. 81.
733083. 733088. 733094. 733104. 733106.
Present, sir.
106.
106.
Okay. 733114.
Sir. Sir.
Tell me.
10114.
Present 1/4. 114. Okay.
Yes. Yes, sir.
733115. 733301. 733302. 733303. 733304. 733304. Absent. Syed Ahad. M.A. Atif. Mohammad Azhar. Asra Amreen. Mirza Asif Beg. Safi Faruqi. Syed Musa bin Hafiz. Riyan Hashmi. Syed Inayat. Nihal Khan. Syed Madani. Abdul Mubin. Syed Mateen. Abdul Mujahid.
Present, sir. Abdul Mujahid.
Syed Noman. Mohammad Khadir Qadri. Syed Shabaz. Sana Sultana. Rutherford Thompson. Saifuddin. Mohammad Zainuddin. Abdul Basir. Syed Mutalib Ahmad. Abu Ansari. Mudassir Muhammad. Faiz Qadri. Sheikh Shoaib. And last, Syed Shah Zoheb. Wonderful. All have been marked. Now, since we have got few more minutes, let's come back to what we were. But tell me one thing, why is the interest level so low in your class? Nobody is interested. Just 4-5 of you attended. It is a sheer waste of time for you. No issues, no problem. We will continue with whoever is interested. So we were here where we found this attribute. Now, till here, have you done it? Have you got any problems in you doing till here? Yes or no? Have you done this till 70 of mine?
Yes, sir.
Okay. See, in this example, what we have done, the transformer which we have used has only one hyperparameter. That is this add bedrooms per room. This is set to true by default. It is often, I would say, helpful to provide sensible defaults. And this hyperparameter will allow you to easily find out whether adding this attribute helps the machine learning algorithms or not. And more generally, you can add a hyperparameter to gate any data preparation step that you are not 100% sure of. The more you automate these data preparation steps, the more combinations you can automatically try out, making it much more likely that you will find a great combination and definitely saving you a lot of time. See, a few small things which you need to understand. See, with regard to this housing data set, see, one of the most important transformation that you will need to apply to your data is feature scaling. See, with few exceptions, this MLAs, machine learning algorithms, don't perform well when input numerical variables have different scales. Like if you open this housing.csv and see, the total number of rooms range from somewhere about 6-7 to about 40,000, while the median income ranges from, say, I think 0 to 12 or 13. That please note that scaling the target value is generally not required. But you definitely need to understand as a Python programmer and a big data analyst that there are two common ways to get all attributes to have their same scale. Can somebody tell me which are these two attributes to have, which we can use to have the same scale, to get all attributes to have the same scale? Who can help me out with this? It is min-max scaling and standardization. Have you in your innings with Python at your college learned on this min-max scaling and standardization?
No, sir.
No. Okay. See, this min-max scaling, many people call this as normalization, is the simplest. And values here are shifted and rescaled so that they end up ranging from 0 to 1. And we will do this by subtracting the minimum value and dividing by the max minus the minimum. And our good friend of scikit-learn provides a transformer called this min-max scaler to do this. And it has a feature range hyperparameter that lets you change the range if for some reason you don't want it between 0 and 1. On the other hand, friends, the standardization is different. What it does, it subtracts the mean value and then it divides by the standard deviation so that the resulting distribution has unit variance, that is variance equal to 1. Unlike this min-max scaling, standardization does not bound values to a specific range, which may be a problem for some algorithms. And which are these algorithms? This can be some problem for neural networks. Generally, these neural networks expect an input value ranging from 0 to 1. But friends, however, standardization is much less affected by outliers. Now, for example, suppose we say a district had a median income equal to 100, which may be by mistake. This min-max scaling would then crush all other values from 0 to 15 down to 0 to 0.15, whereas standardization would not be affected much. Scikit-learn provides a transformer called standard scalar, which is extensively used for standardization. Now we have reached a wonderful juncture where I would say that there are many data transformation steps that need to be executed in the right order, for which scikit-learn provides something called as a pipeline class. to help such sequences of transformation. So what we will do, we will create a pipeline using scikit-learn, but which we will do in the next session, because we are bang at the end of our time. Before we pack up, I just wanted to ask all of you, how do you find these things which we are covering? See, there are two ways of digesting what we are covering. One is you can comfortably enjoy it, what we are doing, and considering that you've been given an opportunity to learn what the industry wants. Second is you can complain saying that this is out of syllabus, for which you will be a loser. How do you find it? Mohammed, Sohail, Sayeda, how do you find it?
I find it interesting, sir. There are new things we learn from Python and
Yeah.
Max also.
See, yeah, please understand, Python is not just displaying hello world. Python is massive. We have been solving this problem. Today is the 4th hour we are solving this problem. We have still not completed. This is how any problem in the industry is solved. Any problem. Our primary aim was to see if the houses along the seashore in California are expensive or not. Just given the housing data set, a real-time data set. So we are fighting with the data set. So many things we have done, which is very, very essential for you to do. If you want to get into the industry in a professional field, you have to do it this way. Otherwise, you can do marketing. For doing marketing, you don't have to do engineering. It's a sheer waste of time. So what I would say, we had a good time till this, and I would say thank you, friends. Have a wonderful weekend. I'll in some time, maybe an hour or hour and a half, I'll share this recording with you. Please go through this recording. Try doing it yourself for you to understand. And please add ample comments so that whenever you open it, even the next time, it adds value to you. It is on. See, you should be such that you should jump and grab the opportunity, because please understand, it's only the crying babies who get the milk. So you have to cry loud and hard for you to understand everything. Otherwise, this is just one more course, you can say. And in any case, for your big data analytics, we are covering the top 10 technologies in the world as on December 2020. The top 10 technologies, wonderful technologies. So you should be thankful or grateful to your college for them having given you this opportunity to learn all these things, and in a practical way. There is no theory which we are doing in this. I don't believe in this concept of theory. The entire computer science is a practical field. Okay, I would only say thank you, friends. Have a wonderful weekend. We will definitely catch up on the next week.
Thank you, sir.
Okay, thank you. Have a nice day.